In this video, I'm going to show you how to measure the voltage and current of all the components of a series circuit. In this circuit, we have two batteries and two light bulbs, all connected in a single loop. That single loop makes that a series circuit. Current comes out of our battery from the positive end, goes through the circuit, and then comes back into the battery like that. So the current flow is in one direction. Now, this battery right here is made up of two individual cells. I know most people call this a battery, but technically the combination is a battery. A battery is a collection of individual cells. This is a 1.5 volt battery, and that's a 1.5 volt battery. At least that's what they start off being. Let's measure the voltage of each battery or each cell. I've set the multimeter to read DC volts or 20 volts maximum. The red lead is in the voltage port and the black lead is in the common port or the ground. The black lead always is in the COM. That never changes. So I'm going to take the two leads and let's measure the voltage of the first battery. And so I'm going to take the red and attach it to the positive end of the battery and the black to the negative end of the battery. And I get 1.4 volts. So this is 1.40 volts. Now let's see what happens if I reverse these probes. I take the black and I attach it to the positive and the red to the negative. Well, that reads negative 1.39. And here I get, that's interesting, 1.40. I didn't expect that. But there is some error in here. The point I'm trying to make is that if you reverse the leads, you end up getting a negative. Okay. I think it's dancing between 1.39 and 1.40. So the placement of the leads indicates the direction of the current. It comes out of the positive and comes into the negative. Out of the positive, into the negative end of the cell. Same thing over here. That's 1.34. And if we take the combination, 2.72. So VT is equal to 2.72, and if we take 1.40 and 1.34, we get 1.74 volts, or sorry, 2.74 volts. And these two numbers are approximately equal to one another. There's always some error because of the additional metal in between the batteries that are being connected. They may be serving as resistors. We may have some voltage leaking, but we see that they're essentially the same. You take the two battery voltage or two cell voltages, add them together, and that tells you what the total voltage coming out of the battery is. 2.72 volts. I'm going to use what I measured for the combination. Okay, so now what's the voltage across the voltage drop across the light bulb? So from this point to that point, there's a voltage drop. So I'm going to put my lead there and put my lead there, and it looks like the voltage drop across the light bulb is 1.34 volts. So V1, 1.34 volts. I say there's a voltage drop here is because some of the energy is being used to produce that light. So some of the energy is being used up. So now we continue to the next light bulb. And it looks like that's it's dancing all over the place. Let's make a better connection here. So, because if I touch it, it wiggles, and that wiggling may cause, there you go. So 1.24. Let's settle on that. So V2 is equal to 1.24. So if you take these two numbers and add them together, that should add up to 2.72. So 1.34, 1.24852. And we see that we are missing some of the voltage. And that missing voltage is probably explained by these three wires, which is also part of the circuit. See, there's going to be some voltage drop here, some voltage drop here, and some voltage drop through the yellow wire. But essentially, we can say theoretically, Vt is going to be equal to V1 plus V2 plus Vn. So that's a rule that we follow. And now we want to measure the current. So let's measure the current from the battery to the first light bulb. So I'm going to take my meter here and switch it. I'm not really sure what I need to switch it to, so I'm going to switch it to 20 milliamps, amps. And so the red lead stays in the milliamp port. And let's see what we get. Let's see if that's a guess and check on my part right now. So, okay, so something's not working. We end up getting a 1. And I don't know if you can tell on the camera, this is barely lit up. So that's not the right setting. So let's try that setting. Okay, that's a little better. Okay, we have a reading here, and it's 181.5.4. Let's round that to the whole number. So the current right here, let's call that current 1, is equal to 181 milliamps, which is 0.181 amps. Okay, so that's I1. So now let's go further beyond that first light bulb. Okay, so I've just clipped that into that light bulb socket. And let's see what this current is. And that says that I2 is equal to 181 milliamps also. So it's 0.181 amps. So that makes sense, is because in a series circuit, the current is the same. The charge plays follow the leader. So as the charge carriers move through that circuit, they play follow the leader, so they're all moving at the same rate. So that tells us that the total current in the circuit is equal to the current through the first light bulb, and that's equal to the current of the second light bulb, right there. And that tells us about the voltage and current in this circuit.